Okay, hi Shada. Sorry, I apologize for the delay in getting the answers to you on the second question that you asked for. We've actually traveled from Peterborough to Sarnia in between, and so now I have a chance to get on Wi-Fi and do this for you. So I chose question 25 because it's a little bit different than the first one, and I just thought then you would get some ideas to apply to the other questions, but I'm also happy to look at those other questions for you along the way as well. With 25, I think that what's best there is for you to use, if it's okay with you, I'm going to leave out the lim as x approaches 0 part, and I'm going to let you put that back in because I'm just going to concentrate on using the identities to simplify the expression that you're working with, and it's just easier for me to write on this big screen if I don't have to keep squeezing in that lim as x equals or x approaches 0, but please don't forget to leave that or to put that in when you do it. Using the quotient identity, tan of x is equal to sine x over cos x. So let's expand on that, and we'll use the same identity, and we'll just write sine of 2x over cos of 2x. And then the 1 over x part, or the over x part, I can write that as 1 over x multiplied by it. So the sine of 2x is a double angle identity, sine x cos x. Maybe we need that, maybe we don't. And I need to go 1 over x times 1 over x here, and I've got I've got cos of 2x there. Okay. So if we rearrange this a wee bit, then I've got the identity sine x, there should be an x up here, over x times 2 cos x over cos 2x. There's other things that we could do if we wanted to with this guy, and we could expand cos of 2x using a double angle identity and so on and so forth. But I don't think we need to do that here because the way that we've got this set up now, I did this on purpose. I was trying to get the sine x over x to come out as its own sort of chunk of this equation, because you are given information in the question. I know you talked about this in class, that there's sort of a limit identity that if you ever end up with sine theta over theta, as theta approaches 0, it's always equal to 1, and the same applies obviously for sine x over x. So if we can get any of these equations to have a sine x over x factor, then we can use the information that we're aware of there, which is that that's equal to 1. When you take limits, if you have limits of a product, you can take limits of the two pieces or the two functions that make that product separately and then just multiply the limits together. There is a rule that allows you to do that. So let's have a look at what we're left with. We've got 2 cos x over cos of 2x. What happens if we put 0 in for x now? Well, cos of 0 is 1, right? It's only sine of 0 that gives us problems. So if we have 0 in here, it's going to be 2 times 1 is 2. And at the bottom, if we have 0 in here, it's cos of 2 times 0, which is still cos of 0, which is 1. So that whole thing comes out to 2. So we have 1 times 2 equals 2 as the limiting value for that function. And again, I just want to remind you, because I don't want you to get this back and go, oh, there's no limit. She didn't write them, so neither did I. I just want you to write those in, but it's a little hard with the size of my stylus on this white screen for me to fit all that in and write it each time. But every time you write a line of the solution, it has to start with lim as x approaches 0 or lim as theta approaches 0, whatever applies there. Okay, so that's another question that's different than the one that we did earlier this morning, and that one could apply to a few different things that I see in here, so you might want to use that approach. The other thing that I'm going to tell you is that some of these, like this one here, you may need to use the addition formulas of sine, like sine of x plus y, in order to expand that. And again, those are all on that sheet that I sent you with all the trig identities. And so there's a couple of different ways to do these problems, and each one is kind of unique. So if you want to just try them, and if you get stuck, send me your work, and I'm always happy to look at that for you and let you know where you're going wrong, or give you a suggestion about where you can start, or what identity might be the best one to use. So I'll try to keep checking my email. I am away until Monday, and definitely next week more regularly. I'll be able to get back to you, as like right on top of things, but I will also try and get back to you this weekend. If you're emailing me, I don't want you to get frustrated as you're working on this assignment. And happy Turkey Day.